All right. Good morning. Today we are continuing on with our math lectures and stuff. I'm trying on a new thing, and I'm going to put my little picture of me up in the top corner up there. So we'll see if it's better. Hopefully that way it won't block my writing, because I'll just make sure to not use that little bit at the very top. All right. Today we are doing 2.19. And we're going to make sure to put our name and stuff at the top in case it gets lost. The date is 10/10. And we are doing notes. And today we are talking about metric conversions. And more specifically, we're kind of going to be talking about how to use the metric or the conversion method. All right, so the conversion method that we're going to talk about has a lot of work shown required, unfortunately, but it's the best way to really watch your units change through the problem. And it might seem a little silly doing it now, especially with metric things, because metric are always out of 1,000 or related to each other just with powers of 10. It's good practice now to do it. Just like later in math, it gets much more difficult. Same as I've kind of been saying the entire time so far in math. So let's take a little bit of a look at this conversion method and see what it does. I'm going to use the property of multiplication, and it's the multiplication identity property. And if you recall, this one just says that any number times 1 is still the same number. So I can write it like this: A times 1 equals A. It doesn't change. So what I need to make sure that I do every time I'm doing my conversion method is that I'm multiplying by 1. And then I won't change the number. Okay? So first let's take a look at some of our units. We're going to be looking with 3 styles of unit. We're going to be looking at length. We're going to be looking at mass. And we're going to be looking at volume. Now, our length unit is our kind of general unit that we're going to be moving everything to, which is like the base unit, is, let's write base unit up at the top. And we're going to call these meters. It's about a yard. It's about that meter stick is going to be a meter, okay? And it's pretty long, but we can still use that reference meter to measure a whole amount of different things. We can measure the distance of an atom, and we can measure the distance between the sun and Earth. 2 very, very different things, but we can still use them if we just use enough of them. Our mass, our basic unit, is going to be the gram. And the gram is, I like to think of it as about 1 paperclip. So it's pretty small. And our volume measurement, we're going to call a liter. And a liter is, if you ever have a 2-liter can of soda. Oh, actually, I have one right here. This is a little bit larger. This is 1.25 liter, so a little bit shorter than this. But the idea is kind of the same. It's like one of those smaller soda cans is kind of a good way to do it. Okay, so these are going to be our base unit. We have our meters, we have grams, and we have liters. And this is going to be kind of the key for everything else. So what this section is going to ask us is, it's going to say, if you have 340 centiliters, how many liters exactly is that? And here's how we're going to kind of do that, and this is the conversion method we're going to use. So let's write our little problem. We have example 1. And it says we're going to take 340 centiliters and we're going to go to liters. So my first question should be, what's a centiliter and why am I using it right here, and how does that match up to a liter? Well, I've attached to your homework, and I'll attach it in this YouTube video as well, this table, which I really like. Now, one of the big problems with this table is it looks like it was copied very poorly, or it was copied like 1,000 times, and every time it got a little bit grainier and grainier. But the data in here is set up exactly how I would like it to be, and it's the easiest way to look at this table and to use the information. Okay, so this one I can tell that we are using liters, and we are looking at centiliters. So that means I'm going to look at this third section. It says a metric conversion table for volume. Okay, so I'm going to look where my centiliters are. Right here, CL. Because I know that centa is kind of like a little c, just like in centimeter, and it means 100 of the above. Oh, and I can see 1 liter is 100 centiliters. Okay, so what I'm going to do is I'm going to write this in a very specific way. I'm going to write 340, and this is the way that I want you to write it on your homework. So there's going to be a lot of these big things. You'll see in a second. 340 centiliters. I can even write it how they wrote it. A little c with a big L with centiliters. And then now I need to multiply it by something to change the unit that I want it to be. And remember, I'm going to use my multiplication identity property. So if I multiply this by like 17, it changes the whole thing and I no longer have an equivalency. But if I multiply it by 1 and I just change the units, I'll still have the same thing that I had before because A stays the same. So I need to write something that's equivalent to 1. So I'm going to make a big huge fraction right here, and I'm going to cancel out centiliters. So if I have centiliters on the top, I need to make sure that centiliters is on the bottom of my fraction, because if I ever divide a unit by a unit, I can cancel them out and they're gone out of my problem. So that's nice. So if I have centiliter up here, which is kind of like the top, because every fraction has like over 1, right? But I'm going to put centiliters on the bottom. Now if I have centiliters on the bottom, I need to make it equivalent, so I'm going to put my liters on the top. And then I have to reference my chart. Okay, how many liters is equal to one or how many, what's my equivalency between liters and centiliters? 1 liter is 100 centiliters. So 100 centiliters is 1 liter. And I can write this because it doesn't matter which way I write it, as long as I make sure they're the same, because 1 liter is 100 centiliters. This is equal to 1. I could even say multiply by 1 if I want, because 1 doesn't matter. And this whole thing is 1. It's equivalent, it's the same. All this is going to do is change my units around, which is my key. Now this is kind of how I do the math part. Okay, I have centiliter and centiliter. I can cancel them out. Now I have 340 divided by 100, because notice 100 is on the bottom. So I can take my little calculator. I forgot to grab a calculator. Let me get my little phone up and ready. Sorry, should have had it ready before. Calculator. 340. You guys see? Oh yeah. 340 divided by, what was it? 100 equals 3.4. So I can write 340 over 100 equals 3.4. Now the only unit that didn't get canceled out that carries all the way through is this liter. So my answer is 3.4 liters. And this is my conversion method. Now this is a nice one because it wanted us to go towards liters. And if you remember, liter is our base unit. But sometimes we're going to have to do 2 of these in order to get it to our base unit and then back out of our base unit. Let me show you a couple more, because this is kind of a weird style of doing it. Maybe one that you're not very familiar with. Alright, so this next problem, now I'm going to skip to the next page because, as you know, murdering trees is one of my favorite pastimes. Example 2. Alright. We're going to go 5 meters to millimeters. How many L's does that have? I can never remember. Millimeters. Now, if I wanted, I can also write this as mm, because that's the abbreviation, and that works for me. Okay, so I'm going to start off with 5 meters, and I'm going to multiply this by my big fraction. I'm going to set my little line in the middle, and I have meters here, so that means I need meters in the bottom, because I want them to cancel out. And I need to have my millimeters up in the top. So I have my millimeters up here. So now my question is, how many meters, or what is my relationship between meters and millimeters? So I'm going to look up here, because now I am doing length. 1 meter is 1,000 millimeters. Okay, wow. 1 meter is 1,000 millimeters. And remember, I can do this again because I'm multiplying by 1. It's not changing the actual length at all. 5 meters, and whatever this turns out to be in millimeters, is the same length. If I ran it or if I measured it, it would be the same. Okay, my meters cancels out. Meters divided by meters is just 1, which is multiplied by 1 is the same as my problem before. So I really have 5 times 1,000. Now you can do that on a calculator if you like, but I think you can probably do it in your head. So we have 5,000 millimeters. Sure, the number is larger, but the absolute length is the same. 5 meters is equivalent to 5,000 millimeters. And now I've got my answer. Nice. Okay, let's do a couple more. Example 3. All right. We're going to take 25,000 centimeters, and we're going to go to kilometers. And again, if I want, I could write this as km, because what's nice about all the metric units is they have a really cool little abbreviation that makes it nice and easy. Okay, so this is going to be one of those two-step ones that I'm talking about. So we kind of got it when we're going to our reference unit. This time we're going to have to take it to our reference unit and then take it back out. Let me show you what I mean. I'm going to write 25,000 centimeters times... Alright, so I need centimeters on the bottom, right, because I'm trying to cancel them out. And then I'm going to put my meters on the top, because I'm always going to my reference unit. Just like on my very first page, I'm always going to be going to meters, because that's the best way to do it. Okay, now I'm going to look at my big paper and look at the relationship between, I accidentally bent it, sorry, between meters and centimeters. Okay, meters and centimeters. Oh, right, I remember from before. 1 meter is 100 centimeters. Centimeters cancel out. Nice. Now I have meters, but I don't want meters. I want kilometers. So I'm going to have to do this again. Now I have meters up on the top. It's my only unit left because I canceled everything out. And this time I'm going to put meters on the bottom and kilometers on the top, because I really want kilometers to last through, and I want it to be on the top because that's the one that's going to be important to me. So now I need to know my relationship between kilometers and meters. All right, where is my length? Kilometers. Right here. It's all the way up. It's the biggest one we've got. 1,000 meters is 1 kilometer. Is 1 kilometer. 1 kilometer is 1,000 meters. Okay, so now my meters cancel out, and I'm left with kilometers. So I really have to do 25,000 divided by 100 divided by 1,000. So I suspect it's going to get a bit smaller. Okay, let me get my little calculator up again. And if you can do this in your head, awesome. I'm just going to do it on my calculator just for a little bit of practice. Can you guys see? 25,000 divided by 100 divided by 1,000 equals 0.25 equals 0.25. 0.25 what? Kilometers, because it's the only thing left. Okay, see how I went from my initial unit to my unit of measure, back out again. If you feel like you understand it, go ahead and try the homework. We are going to do all of them. I'm going to do probably 2 more if you want to hang out and see. And these 2 will probably be from the homework as well. So it's a nice little beginning. Or you can check and see if you did them correctly, which is kind of nice. All right, so let's look at example 4. Example 4, actually I'm not going to do from the homework, but example 5 will be. So we're going to go 2.4 meters to millimeters. Okay, I'm going to start off with 2.4 meters, and I'm going to put my meters on the bottom because I'm trying to cancel them out. And the question I need to ask myself, oops, that's a terrible M. Don't judge me. Is how many millimeters are in a meter? Units of length. How many millimeters are in a meter? Wait, that's weird. That's not what I want. 1,000 millimeters are in a meter. 1,000 millimeters are in 1 meter. Okay, so now I'm going to take my meters cancel out. Nice. So I'm left with just millimeters. Well, I turned my weird one into a correctly written one. So now I'm really going to do 2.4 times 1,000. Okay, let's do that. 2.4 times 1,000 is 2,400 millimeters. Nice. I'm done. And then let's look at example 5, which is going to be number 1 from our homework. 1,000 centimeters to meters. 1. All right, I'm going to write my 1,000 centimeters, and I'm going to get rid of centimeters, and I'm going to put my meters on the top. So the question I ask myself is, meters and centimeters, 100 centimeters equals 1 meter. 100 centimeters equals 1 meter. Okay, so I have 1,000 divided by 100, which is going to be 10. My centimeters cancel out, and I have 10 meters as my answer. And that's kind of what it should look like. I want to see all of this big conversion in all the things that you do. Go ahead and go on the homework. We did not use our volume very much, or our mass, but the same idea kind of carries through. See if you can figure it out on your own. If you can't, ask me or another adult, and we can do our best to help you through. Good luck.